students, welcome to all. I am Kannadasan, Associate Professor of Computer Science and HOD, Department of Computer Science, Thandai Periyar Government Arts and Science College, Tiruchirappalli 23. Now we have some lecture on number system. As we know, numbers are count, a value or some weightage. System means an integrated components linked together to do a job. As an example, a computer is a system, whereas a bicycle is not a system. A home theater may be said to be a system, whereas a tube light may not be a system. So let us discuss about decimal and binary number system. First of all, we can have discussion about a decimal number system. So the decimal is derived from the Latin word decimus, which means tenth, which contains 10 different symbols, namely 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the base or radix of the number system is 10. Since we have 10 different symbols, the base is 10. So in the general format is, we can have an integral component, a decimal point and a fractional portion. As an examples, 1, 3, 4, 5.67. This is one of the example for decimal number. So here the point represents decimal point and the values after the decimal point is called fractional value. So generally in mathematics we have to write the suffix for the number system. For example, 89.45 can be written as 89.45 base 10. This contains integral value, decimal point and fractional value. Next, the value 500 is another example which contains only integral value, which can be written as 500 base 10. As another example, we can have 0.56. This can be written as 0.56 base 10. So in this example, we have only fractional value with base 10. So with respect to binary number system, which is derived from the Latin root word bini or bini, that means two together, which contains two different symbols, namely 0 and 1. Generally, 0 is written as 0, that is the value 0, which should be distinct from the character O. So for writing binary number, we should write 0, within 0 we can have a cross, so that represents a binary 0. The general format is which contain integral value, binary point and binary fractional value. Since this contains two different symbols, the base or radix of the system is 2. For examples, the value 1, 0, 1, 1, 1.1001 base 2. So in this value, the values before the binary point is integral value and the point is said to be binary point, and the value after the binary point is called fractional value. So we can write mathematically 1.001 base 2. Here a binary number is contain integer value, binary point and binary fractional value. Another example is 100 base 2. So this value contain only integral value, which is a binary value. We should not call it as 100 as decimal value. Another example is 0.111 base 2. So in this example, we have only binary point and binary fractional value. Some of the invalid examples are 3, 4, 5 base 2. This is invalid because the symbols 3, 4, 5 are not binary symbols. Actually, they are decimal symbols. Another example is 1, 0, 0, 1. This is actually 1001 in decimal. Since the base is absent, this is not a binary value. Next one is octal number system. In the octal number system, we have 8 different symbols, namely 0, 1, 2, 3, 4, 5, 6, 7. So the base and radius of the system is 8. Generally, the word octal is derived from the Latin root octo, which means 8. So the general format is octal integral value, octal point, and octal fractional value. So as an example, 6, 5, 4, 1.245 base 8. Here 6541 is the integer portion, and the point is called octal point. 245 is the fractional portion, and the base or radius of the number system is 8. We can write the octal number system mathematically as 2350.0117 base 8. This is a valid example because the numbers or digits are within the octal symbols. And next one is 1008. So this is octal integral value, 0.151 base 8. This is octal fractional value. Some of the invalid examples are 395 base 8. Here the digit 9 is not in the octal system, so this is an invalid example. 2367. So in the subscript 8 is absent. That is why it is not a valid octal number. Next we pass on to the hexadecimal number system. Hex means 6, which is derived from the Greek word hex, and decimals means 10, which is derived from the Latin root word. So 16 is a hexadecimal number system. The base of the number system is 16, and which contains 16 different symbols, namely 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Actually, the symbol A is equal to 10 in decimal number system, and B is equal to 11 in decimal number system, and C is 12, and D is 13, and E is 14, and F is 15, and the base or radius of the number system is 16. The general format is integral component, hexadecimal point, and fractional portion. For example, 9, 4, A, B, point, F, 0, C, base 16. In this example, 9, 4, A, B is the integer portion of the hexadecimal value, and the point is hexadecimal point, and the value F, 0, C is the fractional portion, and the base or radius of the number system is 16. Valid examples or invalid examples are shown. The valid examples are A, B, 4, 5, 8, D, E, 7, base 16. Here all the symbols are within the hexadecimal specifications. 1, 0, 0, base 16. This is an hexadecimal integer value, the base 16. 0.982 base 16. This is another valid example for hexadecimal fractional value. Some of the invalid examples are 3, G, 5, 4, H, base 16. Here G and H are not in the symbols of hexadecimal digits. 2, 6, 7, D. Here the base is absent. That is why it is an invalid example for hexadecimal value. So this is the summary of 4 number systems. So decimal number system, binary number system, octal number system, and hexadecimal number system. So with respect to decimal, the base or radix is 10. 10 different symbols are there, and the valid example is 786.63 base 10. For binary, the base is 2. Valid example is 1101.1011, and the symbols are 0 and 1. For octal number system, the base or radix is 8. The symbols are 0, 1, 2, 3, 4, 5, 6, 7, and the valid example is 4352.103 base 8. The hexadecimal symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, and the base of the system is 16, and the valid example is 6C2B.FEA2 base 16. So this is the polynomial representation for decimal number system. So from the summary of the number system, that is a decimal, binary, octal and hexadecimal number system, all of the computer science students and those who are interested in electronics field are to be well versed in this number system, which is helpful in designing electrical and electronic circuits. Thank you.